Welcome to part 3 of the Data Visualization 2 workshop. This part deals with Shiny Basics. This is a longer section. This is, in a sense, the core section about what the actual code in a Shiny app looks like. And I'm going to follow the sections on screen here. I will quickly walk through an example from the web page, and then I will repeat the same kind of thing in RStudio, and we'll be able to edit and make some modifications there and see what goes on. So in the Shiny gallery, let me just clean up some windows here. I'm going to go, what we'll do live inside RStudio is the Old Faithful Geyser example, which is also here. You can take a look at that online as well. But online right now, I'm going to look at this telephones by region. Super simple example, so we can really just kind of focus on the core things there. And what we have is just a bar chart, not a very glamorous kind of graph. The interactivity is that we can select the region on the left. So this shows some historical data about growth of telephones in the 1950s, basically. We can compare US to Europe, to Africa, to South America, etc., to Asia. And that's our interactivity. Now on the right, you can see the code, and the code is broken into two files. We're going to start with this model of Shiny, the 2-file version, because I think it helps us to see how the interaction occurs. The files are by convention called server.r and ui.r. I advise you just follow the conventions when you are creating this. There's really no need to do anything different. Your Shiny app is whatever sits in a specific directory, right? So once you're in that directory, then it becomes clear, okay, here's the server, here's the UI. And then you don't have to worry about making other modifications because everyone expects to see these two files. All right, so what's going on in the server file? The core of the server part is the R code, or if you were doing this in Python, would be a chunk of Python code in the middle. We are generating a bar plot. The bar plot is really just a plain vanilla bar plot command in R, pulling the world phones data, and that's why we load library data sets, so that we get access to this world phones data that's in those data sets and those built-in data sets. We use this variable input $region. So you might guess from that input that this is the interactive part, right? The region variable is being specified for us, and that's essentially what's going to select the region. So we take the data, and so on screen right now I have Asia. We've got the data for Asia. The main title is simply the value of what we've selected, input $region. So Asia displays. And then the Y label and X label are simply text in this example. All right, so this is a bar plot. If we typed that in R, we would, get something popping up in our graph window. But we are using this Shiny helper function called render plot to make the plot available to the Shiny app. So that is everything enclosed in these parentheses from here down to here. We render it, and then we store it as something called output $phone plot, right? So there's an array of inputs that we can generate and an array of outputs. In this super simple example, we just have one input and one output. but the output is the phone plot, the bar plot that's generated here. And by convention, this is wrapped in a function of input and output. That's pretty much always going to be the way you start these off. And so you've got a lot of parentheses and brackets, but basically it's all to serve up this bar plot. So there's other things going on here though, right? Including notably our input window. That's happening on the UI side, on the user interface side. So let's take a look at that file. We have the same library datasets command because we need to access world phones once more. And here we have several other sort of custom functions that are Shiny functions. What Shiny does is, if you're wondering about that sound in the background, that is the sound of a cat in a litter box. Not much I can do about that. The point of using Shiny is that these little helper functions do the work of putting it into HTML, right? You don't need to write this in HTML. You don't need to mess around with JavaScript libraries or other more programming type of approaches. The fluid page means we're going to generate something that kind of fits the available screen real estate. It can resize itself. And that's the wrapper for the, everything else that's going on here, down to the last parentheses. We have a title panel. That's fairly straightforward. We have a sidebar, right? So sidebar, we start with sidebar layout. And in this case, we have one panel. We could actually have multiple things going on in the sidebar. We have the command select input. It says this is really the core action command on the UI side. We are going to select something we call region. This is user defined, the variable name. The text capital region colon is just the label that appears, and the choices for what's in this box come from the data itself. We are reading the World Phone's data for its column names and mapping those to the choices. HR is simply a hard return that gives this little extra space, and help text just puts a little note in the box. So that's it, right? Our side, but the way the pull down works and the layout, is all done for you. The key is select input. And on the right, we have our main panel. And in the main panel, we have just one command to plot output. So let Shiny know that there's a plot expected to come here. What is the plot? The plot is phone plot. And that's the name of the plot that was generated as output on the other side, on the server side. So the server generates output based on input that comes from the UI side. So on the UI side, you've got to have some function that's generating input. You've got to plot the output typically. And on the server side, you are telling Shiny whatever that is that needs to be plotted, and using the input variables that were put in on the UI side. So it's that constant loop from one part to the other that defines the interactivity. Okay, I hope that's pretty straightforward. I'll take a little sip of tea. And now we'll do the same thing with a different example in RStudio. So I'll just open up my RStudio. And here we go. I will get into my R folder and my data topics folder. Excuse the mess of material here. Where are the folders? Oh, I see. My image is getting in the way. All right, I did want to open up. Oh, put myself back in the corner there, and I did want to open up this little bit of R code because we're going to cut and paste some things later. But to start, I am going to go to File, New File, and when you do this, often you're creating an R script or something. You can also create a Quarto document, but I'm going to choose Shiny Web App. Right. So when we choose Shiny Web App, we get this dialog box that asks us, do we want a single file version or a multiple file? I'm going to say multiple file because so far we've only talked about the UI server model. I'm going to call it Monday Demo. Let me just call it Demo 2, just in case. And what happens when I do that is it generates 2 demonstration files, right, that I could then start editing over. Of course, I don't really need to follow the advantage of following the prompt, right, is it lets you specify the directory where your Shiny app will sit. So here I've just got to kind of throw away demo, so I don't really care. Or you could simply create a directory on your system and put 2 files in it, a UI.R and a server.R. And just like anything else in R, these are just text files, right? You don't have to use RStudio to edit them. RStudio has, many helpful features and things like that, but actually if you were like stuck, right, you had to edit your file on a remote server from the command line, whatever. These are just text files, right? Any text editor could generate them, as long as you have to know a little bit more about the formatting conventions and things like that if you're building it from scratch. Okay, so the other thing that's nice about doing this in RStudio, though, is you can test everything by clicking this Run App button. Maybe a little small on your screen, but where my hand icon is, I run the app and then it actually launches in a little mini window, right? So it is HTML. I could actually ask for it to be opened in the browser and get the same thing. Actually, this helps illustrate the idea of the fluid page, right? The fluid page in the browser, it's very wide. I've got a lot of room, so it displays side by side. It is interactive. My slider causes results. And in RStudio, let me just get back to RStudio behind, this little mini window is also fluid and will resize itself as I change the dimensions of the window. Now, what do we got here, right? Old Faithful is a geyser, a water steam spouting natural feature of Yellowstone Park, and it spouts very regularly, so that's why it's called Old Faithful. And we have the times between eruption of the geyser. So it ranges from a little under 50 minutes to a bit over 90 minutes. And the number of bins means the number of bars that we want the histogram to be divided up in, right? So if we had very few, like 6 bins, we are essentially looking at something like a 10-minute range, actually a little bit less than 10 minutes, it looks like. Let's try. The centering of the bars changes, right, as we change the number of bins, because it's going from the, as we'll see in a second, going from the minimum waiting time to the maximum. And obviously we could go all the way down to 1 bin, which is not that informative, or we could slice it up to, minute by minute, basically, by going to the maximum level. Okay, so that's all that's going on in the interactivity. Let's look at how the code generates that. This time we'll start with the UI side. These start with Library Shiny. I think that perhaps the faithful data is in there. Anyway, when you begin your code, you may want to load any libraries that you believe will be necessary for the operation of the functions inside. Yeah, see, interestingly, on this side, no data is referred to, so I don't think we need the Shiny library. I think that's just, again, a kind of convention to be safe. See, yeah, see, I can reload it without the library Shiny in this file, but there is no harm in including something like that. That is, you know, relatively safe, just to be safe kind of operation. All right, so what's happening? We have the fluid page again. We talked about that. When you were in RStudio, we can highlight the parentheses and see what they match up to. So you can see that the fluid page wraps the entire rest of the functions here. We have a title panel. We have a sidebar, which is generated by sidebar layout, and then inside sidebar layout, the command sidebar panel. We could have multiple components of this, right? We could have different kinds of panel functions, and I'll show you the reference in just a minute. There, you know, there are other types of pages, other types of panels, but let's stick with the simple example first. And our main event on this side is the slider input. We create a variable called bins and describe it as number of bins, and then set the range and the default value. Value equals 30 means the slider begins positioned at 30. Then we have a main panel which simply plots using the plot output command something called dist plot. So what does this tell us, right? It tells us that on the server side we should expect to see something called bins and expect to see something called dist plot. So let's take a look. Here's the server side. On this side, I think we may need the library Shiny because I think that faithful data. Let's try. Let's just take it out and let's try. No. Okay, so we don't actually even need it on this side. The old faithful data is just built in. It's one of the default data sets in R. I think they're including that just to be safe, just to give you an example of like safe general practice. The other thing that's also like safe general practice is this session. The session variable is not actually used here. We can get away with just saying input and output for the function, but there may be other cases. I'm actually not sure of like cases where I haven't used the session variable, but obviously they're just kind of showing you in the sample file that you could specify a session variable as well. But we just have input and output as the core operations here. So we define function input output brackets, and those brackets enclose all this part. And now we're going to generate the plot, right? So the plot is called dist plot. We create it and put it in place with this output $dist plot is assigned by the Shiny function render plot, right? So that's the Shiny part on this side. This side is mostly regular R. And again, if you did this in Python, this is where your regular Python would be, Python code would be sitting. But render plot is the little wrapper function that lets Shiny know what to do with this, right? Generate these plots so that they're ready to be plugged into the graph. Lines 16 and 17, this is a little bit of a technicality of the data. we have our input $bins right here. Right? So that's coming from the UI. And then we say, oh, we want 30 bins, but they actually have to generate a list of 30 intervals from the minimum value of the data to the maximum value. And so that's what's kind of happening here. It's reading in the faithful data set column 2 to generate X, the data, and then generating this sequence, right? Okay, so then we plot this part, lines 20 to 22, is just straight R code. It has nothing shiny and is not actually interactive because the interactivity happened in line 17. Line 17 was we took the bins that were read in and we generated this new sequence out of them. We could even call this bins 2, and just to prove that this part is not coming from the UI side, I'll go ahead and do that. Yeah. Okay, so this is straight up histogram function, data X, number, manually defined breaks in the histogram as generated by line 17, and then just, titles, labels, colors. Okay, so now I would just want to kind of show you that, this is a live thing. Let me change the color to thistle and the border to blue. And you notice that in RStudio, they kind of give you a little background preview of the color. The color names, right, is something you can look for websites on that. You can also just type colors and, see all of the named color options that you have here. Actually, I'll try Thistle 3 just to be different. It actually does not look, it's just a slightly different shade, isn't it? Thistle 4 is a bit more different. I'll change the label. How long to wait? Just typing some not very unimproved labels, but just to show you that this does change when we edit this, right? The color of the graph has changed, the labeling has changed. What has not changed is the input that happens on the UI side. So let me go over to the other side, change the UI. So if I call it unreliable geyser data, I change the number of bins. I say, 1 to 50, that's just way too much. Let me do 20 to 40 with a default value of 22. And save it. Actually, if I say reload, it's going to warn me. If I didn't save it, it's going to say you need to save it, and I'll say save. We could by default have it automatically save, up to you. And now our data is unreliable and the number of bins has changed with a default of 22. Right. So you can see that this does work. The one thing that you need to be careful about, right, when you're designing this, in addition to matching all these parentheses up, is the name involved. Like, so if I say I don't want to call them buckets, I don't want to call them bins, I want to call them buckets instead, and I make that change on one side, I'm going to break the app. Now it says it can't. There's a funny little error, and it's unable to generate that graph now. So to fix that, I'd have to go over to the server side, and instead of input bins, say input buckets. Run it now, it should fix that. And the same goes for the name of the plot, right? If I say, instead of dist plot, I want to call it my plot. If I can type that properly. And run the app. Well, now it generates nothing, right? Because when I'm on the user interface side and it says plot dist plot, it doesn't find anything called dist plot anymore. Oh dear. And that's the sound of a cat throwing up on the floor, but he's okay. Don't worry about that. Looks like a hairball. I didn't plan for these sound effects in this session, but probably will end up leaving them in because I don't have time to record another one. Okay, sorry about that. So when I say my plot and match it up on both sides, it's now working again. Okay, so let's go back to our master page. All right, we've run through this walkthrough of the UI and server. Now what I'd like to talk about is the app.r version. So this is the part that is in my code over here. And what I'd like to do is I'm just going to copy it and paste it as a new file, right? And it actually doesn't matter where I put it. All right, so let me just run it first so we can see that it is a working app. This is a plot of some data from a built-in dataset, the MT cars dataset, which pops up in lots of R examples. We have the miles per gallon of the cars versus the weight of the cars, and we have the interactivity here is simply that we can click on a point and find out the X and Y value of it. It's actually not the value of the data itself, but just, you know, sort of the coordinates on the where we've clicked. We can click not on a dot, but somewhere else and get those coordinates. So it's really not a it's a sort of a toy example. That's not. But just to illustrate, here we're just illustrating the format of the single file app.r function. And actually, by convention, I should have just called this app.r instead of shinydemo.r. That probably would have been better. All right, but how does this file work? It still has two parts, a UI part and a server part. So the UI part is this first lines 3 to 6, and the server part is kind of the rest. So what was in the UI file, a fluid page or a basic page, this is not fluid, this is a basic page where we're just plotting the one thing, plot 1, and this plot click option is the thing that gives us that sort of pseudo interactivity. So instead of this being a separate file, we just assign it to something called UI. And similarly for the server, instead of the server being a separate file that starts with function input output, we assign that whole thing to server. Here we have two outputs, the plot 1 and then the info that comes afterwards, which is what's listed here as verbatim text output. And then the other difference in a single app.r file is the Shiny app. We launch we launch it with this final phrase that's always going to be the same at the end of every single file, app.r file. Just say Shiny app UI server. Now, obviously we could relabel these and use something else instead of UI and server, but again, there's no point, I recommend not doing that. You just make your code confusing to other people who are used to the Shiny conventions. Yeah, so that's what a single file looks like. We could do the same thing by copying and pasting these two things into, well, again, let me go ahead and do that. I would skip this in a single, in a regular session, but we have time in these online sessions to just expand, and those who are not interested in this part can just zoom ahead. But let me paste in our UI and paste in, I'm just copying and pasting what was in those files over into our Shiny demo instead of what was originally there. And now I can save that, and when I run it, you'll see that it's gone back to our geyser data, right? So again, functionally they're completely equivalent. It's really your choice, your taste. Just a couple of things, if you have lengthier files, the sort of scrolling up and down or editing out of two windows of having the UI and server be just sort of hundreds of lines apart, perhaps in a code, can be irritating. Like, where does the server part start? That's one issue. The other issue is typically you see, like, once something's ready for production, that it's collapsed into a single file app.r, because then okay, I just need to upload this one file, refresh this one file. The management becomes a little bit easier. Okay. And then the final concept here is reactivity. And this is very important. We have not, the reactivity is what makes the graph interactive. It means that we can not only set this pointer once, but every time we move it, the graph changes. That is reactivity. Now, in many basic apps like this, you sort of don't have to consciously worry about reactivity. It works well naturally. However, when you have multiple inputs, multiple outputs, the sequence of how things are generated, and when you want to be sure that Shiny is recalculating something or making a change based on your input, will cause you to pay attention to this concept of reactivity. And I'm just going to talk about it in a basic, simple way right now, and refer you to more info from the Mastering Shiny book. So the fundamental thing to do is to use this reactive function to ensure that something is reactive. So if I insert this onto my server side, and I will just I might miss something here because I have let me I'm just going to copy and paste the whole thing, and I'll have to change my input back from buckets back to bins to make it work. All right, so I'm going back to the 2-file version and pasting this in. And I'll talk about what the meaning of this is first. But first I want to remember to fix that change that I made from bins to buckets, change it back to bins. And before I talk it through, I just again want to run the app, make sure it still works the same way. Yes, and I also changed the name of the plot as well, didn't I? I changed it from dist plot to my plot, and I need to change that back over here. So you see, you have to pay attention to those things. All right, here's our, again, we're back to our original sort of dull gray histogram, and the interface still remains at 20 to 40 bins because that I didn't change that side. But what did I do on the server side? It's pretty much exactly as it was before, except one new line on line 13, where I enclose the input $bins in this reactive command, and that sort of puts a big label on it. It says, make sure that if input bins changes, update everything else, right? That's the essential meaning. So instead of using input $bins inside the function, I now use this thing called my input, which is defined to be reactive. So my input plus 1, the labeling comes from my input, and pretty straightforward change to make, but it's that reactivity. This will ensure that the function is reactive. You'll know when you see it. Like sometimes you're starting to build a Shiny file out and something stops reacting the way you'd expect. That's when you start, remember what I said here, and come back and check it. So I want to just open these links at this point and round out this segment with these. And the Mastering Shiny book, right, as I mentioned in part 1, is really the master reference for this. It has all the details, and it particularly has this chapters on reactivity. So they explain the concept in greater detail, and there's a few. I was just highlighting that reactive function, but there is more to it than that. Sorry, let me click over here. There are some other functions that make use of reactivity. They explain the concept and how to work with it and debug it using this concept of the reactive console. The graph that they describe is useful, right, which helps us illustrate, more complex examples of, inputs being these objects on the far left and outputs being those on the far right of this image on the page. But you might have these intermediate variables, right, that take inputs, generate something else, are passed on to outputs, and this is where you get into this situation of like, I need to make sure that things are updated and passed through properly. So there is a reactive graph that you can generate to debug this and sort of understand the order that R is doing things by default and how to make your edits to ensure that things are happening in the way that you like, right? So it gets a little complex, but sometimes you need to do this to make sure your app is running properly, especially if you have something more complicated going on. All right, so with those highlights or pointers to the documentation in the Mastering Shiny online book / website, I will stop there, and I will look for you in part 4, where we talk about publishing your Shiny app.